where I'm from the Fudan Microelectronics, and our motion is quite simple, and because my colleague brought a Model 3 for his wife, and during a sales promotion, and definitely a good husband, right? It's saving the money and pressure his wife. And Tesla Model 3 has equipped with phone keys and key cards in addition to traditional key fobs for better driving experience. And we are very familiar with contactless start card and RFID chips, and we are familiar with side channel attack and countermeasures, cyber physical system security. So we decided to perform a detailed security analysis aiming at Tesla keys, and especially for key cards and the phone keys. And our analysis require a comprehensive understanding of the implemented protocols by Tesla. And unfortunately, no official documents from Tesla was available regarding the pairing and the authentication protocols. And therefore, we should reverse engineering the protocols first. And here is some information with a key card. And this IC was manufactured by NXP. It's widely used in banking, payment, and national ID and electronic passport. And it has achieved a common criteria year 5 or year 6 certification, which means those products support crypto operation such as RSA, ECC areas, and with side channel countermeasures, such as simple power analyze protection and timing analyze protection and faulty injection protection. And but we can also sniff some communication data between the key card and the vehicles. And there is a lot of commercial and spy device such as microprocessor MP300 and on nevertheless, and it's quite useful. And we just put the spy device parallel to the key card and on the card reader of the vehicle, and catch all the communication logs. And then during our test, we use 3 different key cards for our testing. And this would definitely help us to understand which part of communication data is related to the key card ID and which part is absolutely random and might be encrypted. And according to the sniffer data, the authentication of key cards is based on 16 bytes challenge and response. And the key card and the Model 3 would exchange the public key first. And that's what we need know from the communication logging. And we don't know the cover parameters and the relationship between the challenge and the response. And so we decided to take the official mobile application named TESmLA as our entry point, because it will contain more information such as crypto operations and Bluetooth HCI log information. And there is lots of widely used tools for reverse engineering the mobile application. We can perform text analyze and dimensionally analyze with JetX, IDA, and so on. And honestly, we don't like reverse engineering, but we have no choice. And after all, we find it's the cover parameters is needs to P256, and we saw a Java object on the app with some ECDH operation and AES operation, and we started to guess, and the challenge and the response and must be related to the ECDH shy secret and the AES operation. And so we established the protocol. And the authentication and pairing is quite simple. And if you have an unpaired key card, and you just swap on the key card reader on the vehicle, and the vehicle will read its public key, and then you need a paired key card to perform authentication. They would first exchange the public keys and perform ECDH key agreement to generate a shy secret, and the first 16 bytes of a shy secret would be used as a AES encryption key for encrypting the challenge from the vehicle, and the vehicle would verify the response. And if everything is okay, and you will get a new paired card. And there's no security problem, but we find that during the key pairing, TESmLA has never verified its key card certificate, and this would make unofficial key card works. And if you brought unofficial key card from the third party or anyone else, this might be a backdoor in a command to read the ECC private key out. And there's here is an example about hacker says he has found a way to remotely control lots of TESmLA EV cars around the world, and that was leading to unofficial product or program execution on the TESmLA. And next, we were talking about the key pairing and the phone key pairing. And it's quite similar to the key card. And first, unpaired phone key would establish Bluetooth communication with the vehicle, and they would exchange their public keys with each other and change some additional information. And then you need a key card for to perform the authentication. And if everything goes right, and the vehicle will record the phone key's public key, and the vehicle the phone key will record the Bluetooth MAC address and the public key of the vehicle. And if the phone key has already been paired, and when you put your phone key in your pocket and you're approaching the TESmLA, and the phone will automatically connect with the vehicle based on the Bluetooth MAC address, and they would perform the ECDH key agreement to generate the shy secret. And then the phone will send the first attestation A from to the vehicle, and here is the format of attestation. You can find this ciphertext is encrypted by AES GSM mode, and you can find the GSM counter and a GSM tag in the payload, and the vehicle will verify it with the shy secret, and will respond a token. It's 20 bytes, and the phone will send the next attestation B, and the attestation B is also encrypted with AES GCM, but the token G would be used as additional authenticated data in the encryption. And finally, the vehicle would verify the attestation B, and the car will be unlocked, and you can drive away. And we perform a security analysis. We found it's quite a it's no big security problems, and the private key protection is very well, and the key card and vehicle private keys are both securely stored in a secure element, and which is a high security level chips, and achieve the common cartel certification. And the phone key private key would be protected by the key store features of Android. And the GCM counter was used to protect to protect from the replay attack, and but we still find some potential issues, such as TESmLA do not enable the Bluetooth link layer encryption, and the vehicle always advertising its MAC address with a static one, and sometimes we find the update of the token G does not depend on the change of connection states, but it remains fixed for a couple of hours, and we think it's susceptible to a relay attack or man-in-the-middle attack. And if you have two attack devices, one would be fake as a TESmLA, and one would be fake as a phone key, and you can perform a real-time message relay. And because the token remains fixed for a couple of hours, you can also perform the attack with only one device. But you need to have a round-trip message relay. And a Bluetooth relay attack is widely has already been researched for many years. And the easiest way is the GATT layer relay, but it has disadvantages of if the two devices enable the link layer encryption, it will be failed. And another relay attack is a link layer relay attack. It was announced by NCC Group last year, and he can release the link layer encryption package, but you need the right to customize the link layer stack, and I think it's very hard because the link layer stack is a property of the chip manufacturer, so you can't get it from the open source. And the last way is analog relay, and it's quite simple. It just amplifies the physical signals, but it has a limitation of relay distance. And we think TESmLA has not introduced any countermeasures or security features in Bluetooth. It just works as a communication channel. So we think the GATT layer relay attack would be suitable for us to perform a proof of concept. And the attack phrase is quite simple. First, you need to get the MAC address, the Bluetooth MAC address, and the public key from Model 3. And because the vehicle is always broadcasting its public key and the MAC address. And then you need to customize a device and change the MAC address of this attack device, same as the Model 3. And then you get the attack device and approaching to the phone key. The phone key would automatically establish a connection with the attack device and send the first attestation A, and the two devices would relay from to the other hand, and the vehicle was respond with the token G, and you can get the next attestation B, and the attacker will get attestation A and B as a pair, and in this scenario, we think you can get a lot of couple of attestation pairs for further usage. And unlock is quite simple, and if you just walk approaching to the vehicle and send the two attestation to the vehicle, and TESlA would unlock, and you can drive it away. And if the token has not been changed in the next few hours, and you can open it and lock it with multiple times. And to perform the proof, the concept of, and we first needed to customize the Bluetooth firmware and disable the MAC address of the location during advertising, because it's a Android virtual. And we also customize the Android's phone box and enable the ability to modify its Bluetooth MAC address, and TESmLA application for the GATT relay attack. And it happens absolutely silent in the background, and out of the awareness of the car owner. And we think there's some countermeasures to prevent our attack. First one is TESlA has introduced a feature named pin to drive, but we think it's worth nothing, and the feature is disobey the intention of keyless entry system, and it's not default setting of Model 3. And we think TESlA should refresh the token G frequently, and definitely it's refreshing the token fast enough will reduce the attack windows, and enable the BLE link layer encryption is also worked, and it will improve the difficulty of analyzing and device spoofing. However, it's just a securement did by the NCC group, and as I mentioned before. And I think at this moment, the final way would be time of flight, the keyless entry system, and can improve the time of flight to avoid the man in the middle of the relay. And we start our project in 2021, and we almost 5 months later, and we informed the TESlA, and 3 months later, and we get the CVE, and here is information for more disclose. And we would like to thank everyone here to have an interesting.
So in order to perform the attack or attack,
Yes,
you'd have to be right there and right next to the actual key, correct? Because of the Bluetooth low energy range. So you can't do this at distance.
yes, we can do this with the distance, because we can no limitation. If we will pocket the parts on advantage, it also works.
So at how far can the attacker be?
And for the relay attack, it has no limitation, but you need to put your attack device close to the phone chips, and the distance we find it's almost 100 meters.